Hey Finxters, and welcome to today's video about Python's built-in issubclass function. So this is one of 50, 60 Python built-in functions, and all the built-in functions are very important. So every coder should understand all built-in functions, and therefore I just go over all built-in functions and explain them in this video series. Okay, so this video is about Python, about the Python function issubclass, and so the basic usage of the function is with two arguments. The first argument is a class, and the second argument is a class. The first argument is a class for which you want to check whether it is a subclass of the second class. So let's have an example. Say you have maybe you don't know about inheritance, so I will explain it slowly in a Python shell. So say we have a class car, and now our car might have some methods, might have some attributes and so on. But I will just ignore it for now. I will just use pass, which is like a dummy value. So I create a class car, and this class now, every car, for example, has some properties or some attributes. For example, the number of passengers that have space in the car, or the maximum speed limit, and so on. Okay, so it could have many attributes. It could have methods such as accelerate or reduce velocity or so. So you can now create your own custom class. And now you could have another class called Porsche. Okay, and now you could have all the methods that you implemented in the other class, in the car class, you could implement as well in the Porsche class. But as Porsche, every Porsche is also a car. So there's a relationship like this. So you have the car parent class. It has some properties, boom, 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 and some methods. And now you also have another class Porsche. Okay, and the Porsche is just a brand. It's just another car. So actually a Porsche. So if you buy a Porsche, it's also a car. Okay, so therefore we say that Porsche inherits from car, and car is the parent. And of course there are other cars possible. So for example, you could also buy a Tesla, and now Tesla would also be a car. Okay, so we have both of them have the parent car. Both of them inherit from the parent car, but they may have different properties. For example, here the full property may be say diesel, and this one here, the full attribute or property, may be not available at all because it's an electric car or so. Okay, so they can have the same parent. Both of them have a number of seats, for example. So both of them inherit some attributes from the parent class car, but they may have different attributes altogether. Okay, so this is like the idea of inheritance, that you don't have to rewrite all the attributes, the common attributes of a parent class. Okay, so Porsche may inherit from car, and this is how we write this. Okay, so we have the parenthesis, and we pass the parent class into it. Okay, and this is how you can create complicated hierarchies of classes. And for example, here Porsche, it may have a speed attribute, and we set it to 200 or so. Okay, so now Porsche is different from a car, clearly. Okay, so now we can have, like, I can have a property, an instance. For example, my car, I just have a car, and your car, your car may be a Porsche, so you can create a Porsche like this. Okay, so this is how you can create instances. And now if you wanted to check whether a car is an instance of a class, you can use the function isInstance. You pass your car, for example, into it, and we check whether your car is an instance of the class Porsche. Okay, like this. And if you run this, we get the output true. Yes, okay, so your car is an instance of the class Porsche. Yet let's check whether it is also an instance of the parenting class car, and it's also an instance of the parenting class. Okay, so your car is a Porsche, but Porsche is a child class of the parent class car. So therefore, if you check isInstance your car of car, it's also true. It also returns true. Okay, but this video is about the issubclass function. So what is the difference between issubclass and isInstance? Basically, for the isInstance function, you check whether an instance or an object, a concrete representation of this, like Porsche, is still a class. And now you can have for example, in this example, we can have many different instances. So the instances are then real cars like this, okay? So this is probably the worst Porsche drawn ever, but it is one. Okay, and you can have many of those instances that all have all are created by the blueprint provided by the class Porsche. Okay, so all of them have a speed limit and so on, but they are independent instances. So they can have a different current speed, different number of passengers currently traveling with it, and so on. Okay, so basically, let's go back to the code. We can check is subclass, and now we have to pass one class. So say we check Porsche, and we check whether Porsche is a subclass of car. So basically, we don't need the instances here to use is subclass. The function is subclass. So, and if we run this, the return value is still true because Porsche is a subclass of car. So it basically checks the parent relationship. And for example, if you would do it the other way around, so you check whether car is a subclass of Porsche. So what would you expect is the output here? You can pause the video and think about this if you want. So the output now is false, yeah, because car is a parent class of Porsche, so therefore it is not a subclass of it. Okay, and so let's go back to Porsche. So I have another example, Porsche and int. Would this even work, or would this throw an error? What would you think? So now we pass the potential subclass and the potential parent class integer. So subclass Porsche and parent class integer. So this would work, of course. Integer is just a class name, okay? But the result is false because Porsche is not a subclass of integer, obviously. Okay, but then you can do another thing, and this is to pass multiple. So as a second argument, you can either pass one class, like the class car we have previously seen, or you can pass many different classes, like a tuple of classes, and this is what we have done here. So we pass car integer of float, and what it does basically is to check whether the subclass, or whether Porsche is a subclass of any of the classes passed as the second argument. So basically it's an OR relationship. So we check is subclass Porsche car, or is subclass Porsche int, or is subclass Porsche float. And what would be the output of this OR relationship? Yeah, correct. It would be true as well. So we have we check Porsche is a subclass of car, and this is already true. So therefore, it would return true as well for this check. Okay, so then this is what you can use. And so say let's have another example. Say we have a class grandparent. Then we have a class parent, which inherits from grandparent, and we simply set this to pass as well. And then we have another class, child, which inherits from parent, and we pass as well. So let's open the drawing board again, and so now we have the grandparent, and we have the parent, which inherits from grandparent, and then we have the child, which inherits from parent. And now we may have many instances of the child, many instances of the parent, and many instances of the grandparent, for example. And with this instance built-in function, we could check the instances. But now the question would be, what is if we pass child, and is it an instance of is it a subclass of grandparent? So what would you think? What is the output of this code snippet? Yeah, the output is still true because I mean any child here, any child instance basically is also an instance of the class grandparent. So therefore, child is a subclass of grandparent as well. Okay, so any like if you have any property here, like say IQ, and we set IQ to 200 or so, then we can create a child. Let's call it Tom. I create a child, and now we can print tom.iq. Okay, IQ is defined on the grandparent level, but we can still print it, and like Tom, the child Tom still inherits from the grandparent. So it inherits from the parent, but also from the grandparent. So therefore, child is also a subclass of grandparent, even though child, the direct parent of child, is the parent class, and only the parent of the parent class is grandparent class. So but like indirectly, child still inherits from the grandparent class, and therefore the return of the result of this is subclass function is still true. Okay, so I think this is everything you need to know about the is subclass function. It's very useful to know. It's very useful to understand this inheritance and subclassing relationship, which I have shown here on the drawing board. I mean, this is really basic stuff, but it helps you. It allows you to build some complicated inheritance trees like this, so you can have another type of parent that also inherits from grandparent. You can even have some child class 2 that inherits from multiple parents. So this is like poly inheritance. So it inherits from different classes. It's possible in Python generally, and you can build these complicated class relationships. In many advanced Python code projects, you will actually see those inheritance trees, and you need to visualize them, and you need to check from time to time whether a certain class is a subclass of another class, and therefore it's very useful to know about these Python tricks. Okay, thanks for listening to this video, and I hope to see you in the next video. Thanks for spending all the time with Finxter. I appreciate having you here and listening and watching our Finxter YouTube videos, and yeah, see you in the next video. Bye.